All right, polar versus nonpolar. This is the last column on your Vespers practice worksheet. Okay, earlier I told you we could do a difference in electronegativity. All right, and that difference would tell us whether it's nonpolar, polar, or ionic. Okay, so we're not going to do that. What we are going to do is we're going to look at the Lewis structures you drew, and we're going to determine, is there equal sharing of electrons, which would mean nonpolar, or are we going to have unequal sharing of electrons, which is polar? Okay, so no calculation. All right, so let's look here. When you have a polar molecule, that means one side slightly positive and the other side slightly negative. Okay, they're also called dipoles. So if you hear that term dipole, that's what it's talking about. And polarity depends on the shape and symmetry of the molecule. Symmetrical molecules, meaning it looks the same on all sides, is nonpolar, and asymmetrical molecules are polar. Let's look at this example right here. Okay, we've got carbon and 4-chlorine, carbon tetrachloride. Carbon in the center, single bond chlorine, single bond chlorine, single bond chlorine, single bond chlorine. Looks the same all the way around. So we call this symmetrical. All right, in a symmetrical drawing, it's going to be non-polar. All right, so notice this one's slightly different. I've got carbon in the center, then I've got chlorine, single bond hydrogen, single bond hydrogen, single bond hydrogen. And not symmetrical like this. That chlorine makes it asymmetrical, which means polar. All right, so let's look at our next one. All right, so looking at the shape, we're going to figure out whether it's polar or nonpolar. So see this, carbon's in the center, and all the way around, we've got chlorines, right? Single bond chlorines all the way around. Symmetrical, nonpolar. All right, look at this one. This one's pyramidal. You've got this unshared pair. Anytime you have an unshared pair on an atom, you automatically just write polar. Because look, single bond hydrogen, single bond hydrogen, single bond hydrogen, unshared pair, polar. Water, which we will discuss next semester, is the most polar substance known. Here we've got two unshared pairs, and then we've got hydrogen. Well, what people will try to do is, if I cut that down the center, that makes it symmetrical. This is asymmetrical because it's got unshared pairs. All right, polar. Here's another one. Hydrochloric acid, polar because we've got this chlorine with unshared pairs and then a hydrogen here. But here we've got this boron trifluoride right here. Single bond fluorine, single bond fluorine, single bond fluorine. Looks the same all the way around, symmetrical, nonpolar. Okay. Here are diatomic elements. The Brinkelhoff, remember I talked about that before. Brinkelhoff, if you have any of these, they are always non-polar. Always linear, always nonpolar. Okay, so diatomics, nonpolar. Okay, now you're going to go to your Vesper practice worksheet and you're going to fill in whether it's polar or nonpolar.